All right, Algebra 2. We have the 5.3 notes today, and we've been working a lot with square roots and cube roots and things like that, so radicals. Now we're going to start graphing them. So when we graph a root, if it's an even root, like a square root or a fourth root or a sixth root, etc., everything on the inside must be a positive number or equal to zero. Okay, you can't have any negatives inside there. Whereas if it's an odd root, it's okay to be negative because, like, the cube root or the third root of -8 is -2. So that's okay. But you can't take the square root of -8. So if it's even, it has to be positive or equal to zero. If it's an odd root, like the third root or the fifth root or the seventh root, it's okay to be positive or negative. And the function that we're going to be graphing is kind of based off this parent function right here. So here's our root, the nth root, we'll call it, whether that's a square root or a cube root or a fourth root. But these colored letters like A, H, and K are going to tell us everything we need to know about this graph. So the shifts that are going to happen, let's just take a look at, like, when we have a number on the outside or out in front. So this A right here, if we had a 3 on the outside, it's a positive 3, so it's going to stretch 3. It's a -2, the negative flips it upside down, and then the 2 would stretch it 2 still. So the number stretches it, and if it's a negative, it flips upside down. Now, if we're talking inside the radical, so this green H right here, it's going to move the opposite direction of kind of what we think it is. So we've talked about this before, where if there's a plus inside the parentheses, we're actually moving left. So here we have x plus 5, or the square root of x plus 5. Our graph is going to shift left 5. Whereas if it's x minus 1, we're actually going to move to the right. So inside is left and right because it's with the x's, and the x-axis goes left to right. Now on the outside, this would be like the y's. This is where we do follow the sign, and we've done stuff like this before. So if we have the square root of x, and then the plus 3 is on the outside, we'd actually shift our graph up 3, whereas if it was subtracting, we'd move down. Moving on, we have a function right here, and we want to graph it. We want to figure out where this thing is going to shift. Well, if we have y equals the square root of 49x minus 98, minus 8 is on the outside, we want to make this thing look like our parent function. Okay, so notice there's no number in front of the x on our parent function. So let's try to factor out a number to get rid of the x. In this case, 49 goes into 49, and it also goes into 98. So we're going to factor out this 49. And now, since we're taking the square root of it, well, the square root of 49 is just 7. So we can pull that out in front. This is just like if we were simplifying or factoring down a square root that didn't have x's in it. We can still simplify this number because it's a perfect square. So now that 7 is brought out in front, and we know from our original shifts that a 7 out in front is going to stretch at 7. X minus 2 moves the graph right 2, and minus 8 on the outside moves it down 8. That should actually say down. I couldn't write apparently about a year ago. So down 8 right there. Okay, moving on, we have this equation, y equals the square root of x minus 3. Well, the normal graph of just the square root of x looks like it starts in the middle and it just kind of rises up and over, and it's kind of curved, but it only stays above the graph, kind of like this. And we know that the x minus 3 part is going to move it, it's going to shift it right 3. So we're just taking our vertex and just shifting it over to the right 3. And now we have the same exact shape, but it just starts over right 3. From here, you could, if you weren't confident, you could double check your answers by plugging in x values and getting out y values and just finding some points. We've done that before. But we can also find the domain and range. So domain is how far left and how far right. So what's the furthest left on the x-axis this goes? 3, and then it goes forever and ever and ever to the right. So it's from 3 to infinity. Now range is low to high, and so the lowest point on the y-axis, this is the y-axis, but the lowest point is y equals 0, and it's going to keep going up and up and up and up forever. So the range is 0 to infinity. Last one we have here, just looking at this equation, I know that if we have y equals the cube root of x minus 2 on the outside, that's going to shift it down 2. Now this is a cube root, not a square root. This one was a square root, so it looked like this. But our last example is a cube root, and that kind of looks like a snake right here. And it usually starts down here, and then it crosses through the origin 0, 0, and then it comes up. But since we have this -2, we're going to shift it down 2. So we're just taking the middle of the graph and moving it down 2. Um, the nice part about these cube roots is that the domain and range is always going to be the same, negative infinity to positive infinity, because it'll go left forever and right forever and down forever and up forever. So if you have any questions, shoot me an email or I can answer them tomorrow in class. Thanks.